Hello and welcome to another episode of Conversations in Artificial Intelligence. It is an honor and privilege to have you here. And today we're going to go back in the realm of product manager, building products, and doing lots of interesting things, understanding how users utilize and machine learning and how, like machine learning is being applied in certain contexts of B2B in the medical space, in the healthcare space. With us today, we have a very interesting product manager and entrepreneur, Tom McGrath from Boston. How are you today, Tom?
I'm doing great, Paolo. Thanks for having me today.
Thank you so much for being here. So, Tom, you have a unique story to tell, and you have done a little bit of entrepreneurship, and also you work as a product manager. Tell us a little bit about yourself.
Sure, yeah. So I got my degree in entrepreneurship and corporate innovation at Indiana University. In my junior year of college is when I first really got involved in machine learning. I started a company called Social Sweepster, and we had built facial and image recognition technology to actually help college students clean up their social media. So I'd find pictures of you drinking beers and doing keg stands and get those deleted off your Facebook and Twitter and Instagram accounts before you went and applied for that first job. Shortly, you would say 2 years into it, we had a lot of interest from market research companies who saw that there was this visual trend towards consumer data being image-based. So the emergence of Instagram and Pinterest and Snapchat. And so they said, hey, if you can find things like beer cans and solo cups, can you do things like logos and brands to look at a photo and say, hey, this is an 18 to 24-year-old Caucasian female that likes to run on the beach and wear Ralph Lauren. And so we pivoted to that model and moved to more of a B2B application in which we were offering APIs to social media analytics companies. So around, I would say, 3 or 4 years into it, I decided to go to work for one of our clients, a company called Crimson Hexagon. They were known for their text analytics and their natural language processing, doing things like sentiment analysis on social conversation. And what they wanted to do was essentially what I was doing with the previous company, is build that technology into their suite of products in their workflow. And so I did that for about 2-3 years, built that technology, and then I asked myself the question, well, where can computer vision have the most impact? And there was a lot of buzz at the time around using neural networks to identify diseases and other ailments in medical imaging. And so I had an opportunity where I am now at Nuance Communications to come on board and start essentially building the Apple App Store of medical imaging applications to diagnose, a wide variety of different diseases and pathologies within a radiologist workflow.
So this is very interesting. So for our audience, you see, this is a very, very intriguing experience that starts from building a company in college and then finding its way in applying the technology, selling the company to a larger company, and then developing an expertise and bringing that expertise into a different company. So by the way, it's a career path you might consider. I like to look at your earlier years in the startup, and one of the things that it's interesting to cover is this trend in consumers with images and so on. Can you tell us a little bit more what actually you were trying to find out from these images? What was the business value that you were trying to extract at that time, and how the trend evolved over time?
Sure. So what we really had to do is we had to look at what people were doing with text, right? So there's a whole business built around natural language processing and text analytics and social media, where they're trying to identify trends and topics of conversation, understand sentiment around a particular campaign, tracking things like impressions and engagement. So for example, one use case might be tracking the value of a sponsorship, right? So at a sporting event how many people are in attendance and how many people are watching on TV. But there are all these people posting images of the game where there might be sponsorship and logos on, let's say it's basketball, a backboard, the floor. And so there's all this additional impression and engagement that's happening visually, but it's not being captured via text. So let's say AT&T sponsors the NCAA Final Four. No one at the game is really talking about AT&T typically, but they're taking lots of pictures of heavily branded assets there. And because you have the ability with computer vision and AI to track that, we can understand what was kind of the return on investment that they got from a social perspective on that investment. So that would be one use case.
And so that just for our viewers to understand, so basically the customer here is a media agency that is telling to their customers, here are our results, and our results are more, if you like, extensive that you have believed until today, because now we can measure also the visual engagement of people.
Mm-hmm. Absolutely. So yeah, typically agencies and brands that were purchasing this technology.
So that startup evolved to become a suite, a software suite within another company, a B2B company. So can you talk about like that evolution, and what did you realize in the marketplace in terms of the market penetration or the market opportunity for B2B API services that do something like this, as computer vision to provide analytics services basically to third parties?
This may not be something a lot of people want to hear, but I'm beginning to see that AI is becoming, at least in some respects, sort of a commodity. It's becoming very, very easy to build. We have access to data, cheap GPUs. You can, leverage neural networks from Microsoft, Facebook, almost completely for free. And so specifically as it related to doing things like logo detection, object detection, scene recognition, and all those different areas where a lot of the value now becomes is around the workflow and the outcomes and basically integrating into what people are doing in their everyday lives. I think that just delivering a technology is not is not how you can extract true value, especially as we see more people becoming adept at building these technologies. I think early on when I started, there weren't a lot of people that could do it. But I think with things like TensorFlow and Microsoft Azure, what they're building, it makes it very, very easy and a low barrier entry for people to go and build technologies like these without, having to be some sort of AI expert. And so what's really going to be important is really understanding the business application and integrating with an individual's everyday workflow, understanding what they do day to day, and then trying to apply that technology to what they're doing day to day. And so Crimson Hexagon, when I was there, they were very well integrated into the workflow of the brand analysts and media strategists. And so they understood the things that they wanted to track. They understood what the outcomes were that they wanted to look at and things that they measured. And so he was figuring out how to integrate with that to figure out what the ultimate value was going to be, because that's what people will pay for. They won't pay for a technology alone.
So that's, I think that's a very good point. In what cases do you think people would still pay for a technology alone? Have you ever come across cases like that? Because the reason why I'm asking this question is we're located here in Silicon Valley. Not all the startups, but there is a good amount of startups who are trying to bring new technology to the world, and then after a while they do kind of a product market fit and they look for an application, but they start with a very, very strong technological base.
Yeah, I mean, I would say that it's better to be niche in what you're doing with the AI. If you're just doing something like, for example, like object recognition, there's so many places I can go and buy that technology that it's just not a problem. Also, if I'm a company that I'm in the software world and I have engineering resources, I may not want to build technology to suit their needs. I may want to go into more of an unsexy area where they don't have a lot of experience with AI. They don't have the resources in-house to do it. So something like a construction company or insurance companies, financial services to some extent, they don't have a lot of those technical resources or know-how yet to go and build these things. So they're more likely to go use a service like Google's cloud services or Einstein with Salesforce. Those would be the cases in which I would expect that people will still pay for, especially if it's a smaller company too. I would say mid-sized companies are more likely to try and use these services over building them themselves. Companies that I've been at before, they're very, very large. And so when they're looking at something like this and evaluating it, using it at scale, they may say that, man, we're going to use this so much that it just doesn't make economic sense. We're just going to build it because we're big and we have the resources. But there are going to be a lot of smaller to mid-sized companies who don't, and they have to use those outsourced services. Just like it is with any business, if you're big, and you want to have your own support center or call center, you can afford to do it, you'll probably do it. But otherwise, if you're a little bit smaller, you might use an outsourced service.
So we got basically a AI B2B recipe to kind of be successful. One, look at companies, industries that cannot or do not have the expertise to build AI on their own. Focus on a problem that is fairly complex, but not too complex to solve. And then size-wise, look at companies that have enough cash to pay for a service, but have not enough cash to build an entire department of AI to focus on a specific problem. So they'd rather use an API. So very interesting. See, so you basically have been working in the part of machine learning that goes by the name of computer vision. Probably there's been some overlap with natural language processing. So you developed both, being a product manager, both a business competence in this area, and you went towards B2B, and also you developed a technology competence. So at a certain point, you moved to Nuance in Boston and trying to apply this to a different problem. Can you talk about the problem a little bit and tell us a little bit what it is?
Yeah, so the problem that we're trying to solve is using artificial intelligence within the radiology workflow. So ultimately what they need to do to make more money for themselves is be faster, right? The radiologists are limited in a day in the money that they can make based on the time it takes for them to review something like an MRI, a CT scan, an X-ray. And in some cases, they may overlook things. There may be things that were incidental findings that they were looking for a lung nodule, but there happened to be an aortic aneurysm there as well. And so to some degree, we're helping with accuracy as well. But it really is a productivity play and making them more efficient and really kind of honing in on that value of what people would call the machine learning human partnership. I think most people who are AI experts would agree that the place where we can unlock the most value right now with AI is the partnership between the human and the machine. And so we're using computer vision algorithms, neural networks to identify different diseases, as I mentioned, or just different ailments within these medical images. And one of the problems the bigger problem that we're trying to solve with this marketplace, and so as I mentioned, we're trying to build the AI marketplace for medical imaging applications, is because we have a software now that all radiologists are using, or a large percentage of the radiologists are using. It's about 70 to 75% market penetration right now. And so we have this core system that we can basically integrate with all these different AI algorithms so that the radiologists in these hospitals themselves, if they want to try an algorithm, if they want to try 15 of them, they don't have to go and create integrations with 15 different algorithms. It's a very arduous process. So, similar to like an iPhone, you can just download all the apps you want and try them right there on your machine and run them on the different medical images and whatnot. So we're trying to just make it a very, very easy integration from I have an application, I have a technology. Now, how do I get that into the workflow of the radiologist and the softwares that they're already using?
So we see here that this is quite interesting. There are a couple of topics here that I'd like to expand on. One is you touched upon increasing productivity of the radiologist. But that, if you think about that, there are a couple of components to that. One is also the hardware that they have. Why? Can you explain why the machine learning is such an important parameter, such an important factors in improving productivity for radiologists?
Sure. So let me, explain kind of the product a little bit. So right now, Nuance sells a product called PowerScribe. And PowerScribe is a reporting tool that uses speech-to-text technology. It's actually, if you guys have ever heard of Dragon, we're the company that owns that technology. And so when a radiologist is looking at an MRI, he's typically dictating text into the report. He's saying, there's a lung nodule in the left lower lobe, right? However, with an AI algorithm, we can actually detect that automatically and generate text from that using natural language generation, where the radiologist doesn't even have to speak. He just has to say, I accept this finding. So instead of him talking, it just goes, there it is, accept. And it also helps him jump to the part in the series, because an MRI or a CT chest scan can have 100 different images, right? And so if he has to go through every single image looking for a lung nodule, that can take him some time too. So if we say we've detected the lung nodule in image 5, 10, and 20, that's going to save him a significant amount of time. But in terms of that human machine learning partnership, he's also getting the ability to say that I agree with this. You know, it's not just them depending strictly on the AI algorithm, it's making a suggestion.
So this is, this is about a philosophical and also, if you like, a very practical problem. So the philosophical is lots of people worrying out there that machines will take over our, our freedom, if you like. The more practical thing is, let's look at if a person or a radiologist says, no, I do not agree, what happens? Does he benefits of any productivity improvement in that case, or that's like the type of case where actually the machine is introducing a delay in the process?
Yeah, I mean, in that case, if he's not agreed with the finding, that is potentially a delay. The idea is that they agree most of the time. And so, there's lots of regulations with the FDA that need to be passed, clinical validation, radiologists who have reviewed this prior for it to even being sold. There's a much, much higher bar for the accuracy of algorithms in medical because of the FDA. The algorithms are actually considered medical devices.
Oh, and that's certainly a very, I think it's a very, very important point. Just to conclude on this, I'd like to investigate for a second this one thing and just ask you, being an expert in the field, if any study or any care is taken about this point. Even though a radiologist is a specialist, is still a human being. If he sees something 100 times and he sees that the algorithm is always right, he might get the bias in mind that says, okay, it must be right. And so never say it's wrong. How do you go about avoiding that situation?
I mean, that's a difficult one. I'm not quite sure if there is necessarily a way to avoid that. If they're agreeing with it on a regular basis, the hope is that it is performing at a level that is very, very accurate. And you also have to understand that humans make mistakes all the time too. So if it's being very, very consistent, then the radiologist is agreeing with it, especially if multiple radiologists are agreeing with it, because it's not just one person looking at this. There's hundreds of radiologists who are going to potentially using an algorithm to validate its accuracy. We can obviously put into place, different, I guess, what's the word I'm looking for, safety checks that say, hey, you have to look at this. But other than that, if they're agreeing with it, I mean, to some degree, that's what we hope for. That's the holy grail. If they agree with it and it's working well. But again, we're trying to replicate human intelligence. How do you keep a human from making a mistake?
So this is certainly very insightful. What I believe emerges from this discussion is that precision here is paramount. Like these algorithms, they need to get it right the overwhelming number of times. Like they can get it wrong every once in a while, but most of the times they need to get it right. So when we look at the technology at that level, how do you think a technology like this differs from what is used in the realm of consumers that you were working before? What it is the core that makes it different?
So I would say if you were to balance it between true positives and false positives, in the world of medical, it's better to have more false positives if you miss something, right? I would say in the world of consumer technology, they don't want to see false positives. They want that true positive detection rate to be correct, and they want false positives to be low. But if something's missed completely, it's not that big of a deal, right?
So technologically, you think there is not a fundamental difference, but it's more like how the algorithms are tuned. So for our audience, if you're not somebody that is an engineer or extremely technical, all these algorithms are a little bit like any other device on earth. So there are like nuts and bolts that you can tune and tune them up or down. And so basically what's emerging here is that the probability that the algorithm making mistakes is minimized at the expense that sometimes the algorithm doesn't make it make some false positives, basically.
Yeah, and I can actually give a really good I can give a real life example of the difference between the two. So in social media analytics, if I were to evaluate 100,000 posts that had the word Nike in it, and our sentiment analysis told it was 70% positive, but in reality it was 80%, the impact of that and the outcome doesn't really matter, because directionally I know that the conversation is positive, right? In my world, if it missed 10% of things that should have been labeled as A when it was B, that would be very, very bad, because it's potentially life-threatening.
You know, today there are certain limitations within the machine learning world. Computer vision is one of the, if you like, the technology that has benefited the most. So the last few advancements include some of the infrastructure improvements, as well as some of the algorithm improvements like deep learning and so on. When we look a little bit, you know, further, what do you envision in terms of what's possible and precision in the next few years? Do you think you envision that there's going to be an improvement for your particular field?
Yeah, absolutely. I think that we need to get closer towards what we would call common sense knowledge bases. We need to understand the relationships between objects. So if I take it back to my work in social media analytics, I'll use an example. There's a photo of President Barack Obama, and this is a blog post by actually Andre Karpathy, if you want to take a look at it. He's a very famous computer vision researcher. And it's a picture of Barack Obama, and he's in a locker room, and he's with 10 other guys. There's a couple mirrors, and Barack Obama is putting his foot on the scale of some other government official, and everyone's laughing, right? So today, most computer vision algorithms would tell you that there was probably 20 people in the room. It would tell you it was a locker room, but it wouldn't understand why people were laughing. And it wouldn't understand that the reason that there's 20 people in the room is because there's mirrors, but in reality, there's 10 people. And it wouldn't understand basic laws of physics, like this common sense that because Barack Obama is putting his foot on the scale, it is causing the weight of that particular individual to go up. And it doesn't understand social relationships, that someone being heavy is funny, and that's why everyone in the room is laughing. And I think that once we get to those stronger relationships and giving these algorithms more common sense, the accuracy will increase. So just as we've built these very, very large data sets to do things like hot dog, not hot dog, we have to start building databases that understand the relationships between different objects and things that exist within the images themselves to get to a higher degree of accuracy.
So that's something that I think is worth to investigate a little bit into more detail. So the strategies that, and we can look at this, you know, more from a product perspective. The strategy that you're basically illustrating here is that not only we need data sets of labels, or something that is, if you like, cat and dog, but why don't we build data set that also explain relationship between objects? So that has been traditionally one of the biggest hurdle of machine learning, like lots of operations that go around the data process. Do you think it's really feasible to go down this route instead of, you know, developing a different technology? Or what do you think might be the cost of going down the route of having humans basically creating these databases of relationships?
Yeah, I mean, I don't know if the neural networks are the right way to go with this type of idea, but I mean, people are doing it now. There's a program called the Visual Genome. I think you can go check them out, visualgenome.com, or it might be .org, where they're actually doing this work. They've built a very large database of objects and scenes, and they're starting to map the relationships between those particular attributes. And so I think it's very possible to do. I've seen it done in practice. And I think, you know, just as hardware gets faster, GPUs go down in price, who knows, maybe someone will come out with that quantum computer sometime soon, and we can start using that. It's very feasible. I mean, we have an incredible amount of data available to us. So I definitely think it's within reach.
So that's a discovery for me, and it's very interesting, to be honest. So for our audience, quantum computing is the next generation. Beyond artificial intelligence is basically the next generation of computing that utilize the laws of quantum physics. 10 years ago, when I was a physicist, this was cutting edge research in the lab. But today, even though it's still a pioneering field of technology, there is, to my knowledge, there is no a real commercial application. There are already 4 or 5 or 6 startups have been financed heavily by venture capitalists. So, one other thing that emerges from this conversation is that one of the interesting things is that here we see significant applications in, if you like, for the well-being of everybody, of machine learning to medicine and to healthcare. And yes, on the one hand, you increase productivity, which might also mean some time, maybe in the US, cost of healthcare will go down. So that could be, a positive news. It also means that higher precision potentially means saving some lives. So we see that artificial intelligence in this LSC sector is having some of the some positive, if not very positive impacts. Whereas in the media, very often there is kind of a negative coverage about what could happen taking over the machine. So what is your take about like the actual social impact of machine learning in your area or the areas you've been more close with?
Sure. So I have a couple thoughts on this. So the first is that I think most new technologies create new jobs. Think about Google and Facebook. Jobs like the social media analyst, an SEO specialist or expert, those things never existed before. So we're thinking of all the jobs that AI could take away, but we're not thinking about the jobs that it could create. I do think that there will be a period of time where there is a gap, and I think that companies have to start thinking about basically upskilling their employees to be able to take those new jobs so that they're learning. And perhaps in my mind, I'm thinking that if we're creating all this additional value from AI, we're making more money, I think that the ethical thing to do is actually to reinvest that money into employees to basically give them the skills that would allow them to basically do the jobs that potentially this AI will begin creating. I also think, and this is a little bit sci-fi, I don't know if you've heard of anything about Elon Musk's neural lace.
Yes.
So,
yes.
I do believe that AI and human will begin to merge in a sense. I mean, right now, if you were to ask me what the capital of Peru is, I would just go look up on my phone. So in a sense, I'm already kind of like this cyborg AI. And so in that regard, a little bit further down the line, I think that humans in general will become enhanced and will be able to do things that previously we were not capable of doing. But I think my core answer would be that I generally think that more jobs will be created, just like any new technology, like Google, Facebook, Microsoft, any of these guys. They've created a million jobs that never existed before.
So in fact, there are studies, this to confirm what you're saying, there are studies from the McKinsey Global Institute that forecast about $18 trillion of GDP in the next 12 years to be created worldwide because of artificial intelligence. And so that if you create that amount of GDP, necessarily you create jobs. So those predictions, sometimes they miss by large amounts, either positive or negative, but they are based on studies comparing the economic and technology revolutions in the past. So that there is some truth to that, certainly, and so that informs us. So, you touched upon a point that it's incredibly interesting to me, and I actually believe that human and machine will merge. But let's stay focused around the healthcare space where you work. What do you think some of the benefits we will see as in the course of our life? How will our children experience a better life, a better quality of living because of the conjunction of the human machine paradigm?
Well, I think one of the things is there will be an increase in the quality of healthcare and a more holistic understanding of the patient, because data exists in so many different places right now. It could be your own personal health data, it could be information or research on a particular disease that you might be suffering from. And this isn't in the scope of what we're doing at Nuance in particular, but being able to aggregate all of that data from all these different locations in a quick, efficient way, and then be able to make inferences off that data based on questions that you may have or problems that might need to be solved within healthcare. I think is going to be enormously helpful. I mean, imagine a world where you're sitting in the doctor's office and the doctor is asking you what your symptoms are, and an Alexa type application can look at your health records and historical, research on other prescriptions and say, hey, I recommend that you do this, right? It's combining the collective knowledge of, thousands of doctors into one recommendation, which I think is a pretty powerful thing, as opposed to just one doctor with, X years of experience who read X books, went to, X school. You're kind of getting that collective knowledge with AI that I think will be very, very helpful. So just like the algorithms that we're using right now in medical imaging, it's not one doctor who trained it, it's hundreds of doctors that trained it. And so you're really getting that collective knowledge and making that decision.
And that likely will result in predicting, so first of all, will result in less error, probably. And I would just gather the attention of our public on the fact that even today, with the technology that we have, human error is the cause of several diseases that then become irreparable. Like my mom is one of these cases where there was a human error on the doctor. So only that alone, if you can not eliminate, but at least reduce drastically the human error, that will bring an increased quality of living on average. And the second thing I believe that Thomas is saying is that we can go even beyond that, not only reduce the error, but even kind of expand the knowledge, like expand the medical knowledge by using kind of a collective intelligence of all the facts that are known, the fact about the individual, the fact about decisions that other doctors have made, and the fact about research that have emerged in the meantime over the years. So that's incredibly interesting. And Tom, our time today is coming close to an end, and I wanted to ask you one very last, if you like, relaxing question.
Okay.
In our world, the world of machine learning, lots of people have got interest, and three words have become very, very popular, and you find them almost utilized all together because people don't know which one to use, and that's AI, ML, and DL. DL is deep learning, ML is machine learning, and AI is artificial intelligence. So what is your take about these three? If you had to explain, let's say, a friend of yours that is not in the field, what would you tell them?
So I would say artificial intelligence is the overarching umbrella. To me, anything that can replicate human intelligence, I even consider a calculator artificial intelligence because it's doing a calculation that the human brain can do. And then machine learning, I would say, falls underneath that. That's things like natural language processing. And that's more of the classical rules-based approach to AI. And then I would say that deep learning is actually a subset of machine learning. Is a different set of tools to accomplish it, the same output. So instead of doing feature engineering, which machine learning does, deep learning is actually learning those features from what you're feeding it as the data.
So with that, interesting note, I hope that our audience appreciate our little contribution on making these buzzwords more understandable. Tom, I thank you so much. I thank our audience for being here. If you have any questions, please comment below. If you have requests for similar comment, please comment below. Today we had a very interesting interview with Tom, who is at the same time as an entrepreneur and a product manager in the field of machine learning, and more specifically computer vision applied to the medical field. Lots of interesting insights. If you want more insights like this, please comment below and let me know. Tom, thank you so much. It was a great pleasure.
Thank you, Paolo.